details. So pause where you are, make sure you're learning from the conversation, but there are two major things that we need to pay attention to when it comes to these equations. First things first, A times C gives us negative 45. The factors I think most of us got to, that 9 and negative 5. Any questions about that?
No.
Why those are the factors that we're using?
No.
Thank you, KP. Anybody else?
No, I ain't got no problem with that.
Okay, so please notice, which of these two equations should I then be using?
First, wait.
The first one.
First.
No. Hold on. Yeah, the
Not
first one. The first one.
Why can't I use this one?
You can use the first one first.
So which one am I supposed to use? Either one works.
Yeah, both of them,
Okay.
equivalent. Is that where?
Say again.
Both of them equal 4.
Ah, that's a great mathematical word. Yes, both of them, the two equations are equivalent. Notice, 9x minus 5x, that's still 4x, right?
Yep.
Negative 5x plus 9x, that's still 4x. There's just a different way to write it. Right.
Yo, I gotta check for something because I gotta get my stuff situated.
You need to get your pants situated. Pull those jokers up. I should not see them. That's crazy. Right. You jack Wendy. Pull them up. I see your underwear. It's
You want to
crazy
see him, you keep looking.
I'm telling you to pull it up so no one else has to see it. So, remember, guys, the whole goal is to factor. I need 4 terms so I can group with my factoring. So I group here. And here, what do 9x squared and 9x have in common?
9.
They both have a 9, they both have an x. And if I factor out the 9 and one of those x's, what am I left with?
X plus 1.
Do I need to talk through
No.
why I'm left with x plus 1? There are some of us who may have questions.
Can we go do some group work or something?
I know that is what group works for, but not everyone gets an answer there. Then we have
X
minus
plus
5 in
1.
common.
X plus 1.
Left with x plus 1.
V.
Okay?
Not 1.
Now, there's 2 things. I'm going to pause. If you're good, don't say anything. If you have a question, please ask this question now. What are your questions? Okay? Okay, that's okay. Let's learn from it. Now, yes, KP.
We doing group work.
For part of today, yes. Eyes up here, though. I need you to pay attention to this, okay? Well, pause, because there's a mistake that I'm seeing lots of students make. I am seeing a lot of students from this point just telling me x plus 1 equals 0 and 9x minus 5
Oh my God, you can't do that.
is equal to 0.
No.
Hold up. Let me declare this. These equations are correct.
Yeah.
But the way we are getting there is mathematically incorrect. We need to pay attention to this. What are we trying to use when factoring? Zero product property. And so I need factored form. Guys, do I currently have a factored form where I can use the zero product property? No. We've got to go a step beyond here. Look, right here. When I look at these 2 terms, what factor do they have in common?
X plus 1.
So when I factor out that x plus 1, right? I only cross it out to help me focus my attention. What am I left with?
9 minus 5.
Wow. Once you have the factored form, a product, right? These 2 things are being what? Multiplied. If I have a product of 0, then I can use the zero product property. If you skip this step, that is going to be a major conceptual misunderstanding, which is a huge thing that knocks down your score on the assessment portion, right, or the scoring rubric. So be aware of that. The Friday, not this Friday, obviously, but so from here. I gotta make that so awkward. So, we need to pay attention to this. Don't forget, we would now finish solving. X equals negative 1.
Wait.
Right? and x equals 5/9 or 5 divided by 9.
So you're doing the reciprocal.
Use the reciprocal there, yes sir. Now, I do want to point this out. If this is the route you went, what do 9x squared minus 5x have in common? They both have an x. If I factor that x out, what am I left with? 9x
Squared.
minus 5. Remember, I factored one of those x's out, I factored that x out. Now, when I look at 9x minus 5, what do those have in common?
Oh
Kind
my
of.
God, bro, let me tell you what you
There is
got to do, man.
one number that everything has in common. A 1. So, it's not usually this way, but I can always factor out a 1 if there's nothing else.
Stop talking.
And notice now, what common factor do they both have?
9x minus 5 and x plus 1.
And I'd be left with x plus 1. Do these factors match these factors?
Yeah.
Just a different order, but exactly the same. So that's the thing. You can go in either direction, right? It does not matter. Factor it how you see fit.
Bro, you ain't no French, you a queen.
You have a question, Ty?
I still have a bunch of them.
Any questions before we continue?
I was looking at 45, that's what I said.
You good now then? Okay. KP? You just stretching? Okay.
Without that blue on.
So, please do not forget, I need us to get in class, get seated, and get to work quickly. 8 minutes into class, we cannot be just starting on a bell ringer. And that's 8 minutes wasted when your education matters. We are learning important skills. We're not just learning mathematics. What are we trying to learn in this class? How to learn. Learn how to think. Bryson, what'd you say? What'd you say? How to be a better person, but learn how to think. Learn how to what? Learn. Learn how to make arguments. Learn how to pay attention when people are teaching. Stop. Okay, guys, stop. Your education matters because you've got to learn how to learn. You've got to learn how to think. You've got to learn how to create arguments and work with people for other people's good, which means that we're not making it about us. We're not being selfish and trying to draw the attention on us. We are working towards everyone else's good.
And we gotta add like it to the bare minimum.
So come on. If you are constantly drawing attention to yourself instead of helping others learn, that is being selfish. That's not saying you are a selfish person, but in those moments you're being selfish. Okay. Hey, side conversation, stop. Legitimately, guys, listen. When you have your side conversations, what you're saying is, one, your conversation is more important than what Mr. Kinney says, and two, it's more important than your classmates getting an education. And that's not true. So stop the side conversations during whole class discussion. That's awesome, but not during whole class discussion.
Yes, sir.
Okay. So, we are going to practice solving quadratic equations for a few minutes. And then we're going to go to lesson 6 from the book to learn about one new thing, the last new thing before we end this unit. Did you have a question, Kai?
Yes, sir.
Did you have
Why
a
you
question?
calling me Kaya or
Kai.
why you calling me Kaya?
Who is Kai?
Why are you calling me that?
Did you not tell me to call you that way back then?
She said.
She probably did on the first day of
No,
school.
I
Not gonna lie.
didn't.
Because I wrote it down in my book that you told me to call you that.
She knows somebody.
I was class.
I wouldn't have written it down unless you told me to call you
No,
this.
I didn't. I did not.
Okay. I won't call you Kai anymore. Alright, so we are still looking at our graphic organizer from yesterday. What we're going to focus on is the back side here, where we're applying the quadratic formula and the vertex form. What I need you to do right now is, as a small group, excuse me, I'm still talking, pick one of the equations that we decided to use the quadratic formula on yesterday, and then use the quadratic formula to solve it. We're going to do this at the vertical surfaces. So, we're going to identify just one of the quadratic formula equations, and we're going to use the quadratic formula to solve it. Now, if you do not know the quadratic formula, where could you get it? before you ask Miss Bauer, practice looking in the book. Okay, guys, you won't have Miss Bauer, you won't have me when you are studying, hopefully, at home. The studying part is the hopeful part. Yes, hopefully you are studying at home. And so, hey,
Who is
that's being selfish and distracting instead of letting the
Hey,
whole
who is
class learn.
Ariel?
We ain't learning that right now.
I'm literally trying to give you instructions on what to
They
do.
said, look in the book. They heard it.
What page to look in the book? Do you know that answer? Okay. M1-85 is where you should look in the book if you need help on identifying or figuring out the quadratic formula. So let's get up, let's move to our vertical surfaces, let's collaborate on using the quadratic formula to solve one of those two equations. And go! Let's go! No, vertical surface. Let's go. Actually, all the way through. Let's go. You like to put your head down. You like to put your head down. I'm not letting you do that. Let's go. Right there. That's what it says. Right This is why we're not sitting down, because you're more likely to put your head down here, so we're not doing that. Yes, ma'am. Good, Jay. Okay, cool. Go work. I don't have go.
Can I start recording?
Ladies and gentlemen, let's talk through this. So, there are two things that we need to address. First things first.
See if I had one, like,
Jay Sean. If you put them in your backpack, it'd be way harder for them to take them too. So, let's stop playing the blame game. Or if you want to put them up here, I can hold on to them. But we're not putting them on. So, two things I need to talk about and I need to address. Right here. Okay, that's why we don't put it in like that. Right here, we're trying to solve this quadratic equation, correct?
yes.
So when we solve this, we're trying to find the values of what that make the equation true.
The values of everything.
The values of... What's the only variable, guys? I'm trying to find the values of x. So this is an important detail. Hey, I'm teaching. And Ms. Bauer, can you focus over here on this?
Yes.
So I need y'all to pay attention to this. This group right here realized that first off they missed the plus or minus. But what else did you realize was missing from your formula that most of our formulas are missing? X equals. Guys, if we are solving for x, that formula is literally x equals. When you write out the quadratic formula, that's not going to help you, Bryson. When you write out that formula, you need to write x equals, because that's what you're solving for. Pay attention to this. Then it's a matter of just identifying A, B, and C, which, from what I can tell, everyone identified A, B, and C well. But this is where you're getting stuck, and for no reason. Look.
You know,
What is this thing underneath the radical called? The radicand. Type the radicand into the calculator, and that's it. 6 squared minus 4 times 2 times 2.
They won't have to do it.
Alright, bro, I got you.
If they did like Matthew told us, just saying.
The radicand is what is underneath or within the radical. I got it. It's right here.
Oh my gosh.
What is underneath the radical?
He give me some knowledge.
You good?
Whoa!
I'm just 20.
He just said something, hey, he just said I'm giving him some brain.
Stop, stop.
You heard what
Stop.
I said. You gay.
What did it
Stop.
You gay.
Now y'all are being selfish and stealing away from other people's education.
That was
Stop my education. Stop. You are both in the wrong. Saquon. Your reaction is also stealing away from people's education. Even if KP started it, you gotta stop. Don't react. Right here, 6 squared minus 4 times 2 times 2 is 20. So, when I look at this, that's all I had to do. Now, there are some times when you're going to want to simplify that radical, and I'm going to show you what that means. But I need you to be careful.
5.
Right here. No, it's not 5. Please notice, this fraction bar goes all the way across, doesn't it?
Yeah.
So over here, I had multiple groups do this. where all of a sudden, instead of it going all the way across, they just have 20 divided by 4. We just have 20 divided by 4. But wasn't that fraction bar all the way across originally?
No.
If you look at the formula, this is that formula, right? It is negative b plus or minus square root of b squared minus 4ac all divided by 2a. That fraction bar needs to go all the way across. So I cannot just change it to 20 divided by 4 here. You can't do that, guys. This would be mathematically incorrect. The fraction bar has to go all the way across. So, negative 6 plus or minus the square root of 20 divided by 4. That's a decent place to start. Now, what am I still missing from that for sure?
X equals.
X equals, okay? I need that. I need that x equals. There are some times when you can further simplify the radical, and this is going to help us with the next part of the lesson we're looking at. What is the square root, the inverse of?
Huh?
What's the square root, the inverse of? A square, right? So I want us to look at that 20. Are there any factors of 20 that I can take the square root of because that factor is a perfect square? 20. You okay, dude?
I was doing some links, but you understand? You gotta repeat what
Please stop. 20 is 4 times what? 4 times 5. Now, this is a property that you should have studied in Algebra 1. We may not have, but I'm just going to teach it straight up to you and tell you this. Okay? When I look right here, that square root of 4 times 5 can be rewritten as the square root of 4 times the square root of 5. Okay? So notice we took the square root of 20, we made it square root of 4 times 5, and I rewrote it as 2 different radicals. And that's because I can take the square root of 4.
Now wouldn't that be like 2 and some decimal or something?
Right, but why would I do the decimal? The answer is I wouldn't.
2.8.
Nope.
Oh, you wait.
Square root of 5.
So cool,
The whole point of this is to simplify the radical so that I don't have to get a decimal. Can you get a decimal? Yes. Is Mathia making you get a decimal? Yes. Why? I don't know. It's still making you practice the quadratic formula, which is good, but I am completely okay with you leaving a radical in the answer. Yes, sir. Yep. Tonight.
11.
Tonight.
Okay.
Now, last detail, Trey. Stop stealing people's education from them. Pay attention.
It was my fault.
Thank you, Jay Sean, for admitting that. Right here. Look at these terms. Do these have, yes, and that's the problem, Quan. Do these have any common factors all the way through? Is there anything I can divide 6, 2, and 4 by? 2. I can divide them all by 2. So this can be further simplified by dividing every term by 2. So negative 3 plus or minus the square root of 5, all divided by 2. That's what x equals.
Look at the problem.
Okay?
No, based off.
So you can leave it just like that. I do not need decimals or anything like that. The main thing, and I will say this, you can earn a high score for evidence of understanding just stopping here.
Oh, yeah, what I'm doing.
Okay? Now, this is not going to earn you 4s or 4 pluses, but if you justify it well, you can earn 3s and 3 pluses with this.
Oh, I just
Okay?
But 3
Well,
works.
hold on. But listen, it is good. It is good to practice simplifying this because the last thing that we learn, you will have to simplify radical sum. KP, there's no option. I'm telling you, because of what we're about to study, there's no option with it. Okay, so there is our quadratic formula. Please notice, guys, as long as you go to the quadratic formula, you substitute in and you simplify. The only problem is that there are several places that you can make mistakes in writing the formula. There are several places you can make mistakes in simplifying. That's why I don't recommend the quadratic formula to start. Okay, but it is definitely going to work. Now, let's get back to our vertical surfaces, but this time, pause. But this time, we're going to pick one of the equations where we need to use the vertex form with what? When we get our vertex form, what are we going to use? Inverses with properties of equality. So, pick a vertex form. Actually, sorry, I forgot. Guys, write this work down on the graphic organizer on the back, right, for the quadratic formula, right? So write down what equation you used and write down the work for using the quadratic formula. This is probably the best option to look at, or that one in brown over there to show those steps, but do write the final simplified one. Yes, you may go to the bathroom now. This
What happened to me getting water?
Tristan, where did you come from?
Go get some water quickly, but
Yes.
I need you to write down this work too. For this group, really quickly, I do want y'all to pay attention. Remember that plus or minus? We forgot the plus or minus here. Okay? And it wasn't 44. If you check 13 squared minus 4 times 2 times 16, it was 41. And so it should have been negative 13 plus or minus square root of 41, all divided by 4. And what I would point out is, there are no factors of 41 that you can take the square root of, so you don't actually have to do anything else. Right.
Now,
You
Elise,
can leave it like that.
why would you do that?
You supposed to be looking at that one,
No, we don't.
cause I was
No, we don't, bro.
Ferguson, I'm sorry, I gotta use your.
Eyes and ears, up here please, I need to talk through. If it's not sharpening, it's done.
One more?
Okay, so, a couple of key details that I want to point out about. You said something that they responded to. I watched it. Just stop.
He asked her with something funny. How the heck do you?
Because you did something that she laughed at. I'm not arguing with you. Please stop talking and stop stealing away from other people's education. Right? Eyes gotta be up here to learn. Right. Rise 8. It ain't fun. Turn in your desk so that you can see the board and you can learn something, sir. KP, Ryder, as soon as Ryder's talking, KP, stop talking and listen. Look, what I wanted to remind you of is this, and some of the groups did this very successfully, and one of the groups right here, literally they were staring at it, they said, I don't know what to do first, Mr. Kenny, and I had them, or I wrote this vertex form up here. And as soon as I wrote that vertex form, AJ, you were like, oh, I know what to do now, right? Is that right, though? Okay, guys, please hear me very clearly. Me telling you to write this is not punishment. It is to help you think through, what do I need? I need A. I need H. And once we talked about H, we were able to find that negative B divided by 2A. One of the things I will point out to help you remember H, if you're struggling with it, is what formula is this right here? Quadratic formula. You see the negative b that's right here in the beginning, divided by 2a?
Yeah.
That is your h. So if you know your quadratic formula, you can see your h right there. Use that. For those y'all struggling with k, once you get h, just substitute it back in. That's it. Get your k, set up your equation. Once you have the vertex form of the quadratic equation, what are you going to do? Use what?
inverse.
Use inverses. Okay, Sam, you with us? Eyes up here. Tristan, eyes up here. Gage, eyes up here. Dude, I'm not getting on to you for shits and giggles. It's because I'm trying to help you
I'm not laughing at
focus.
anything, I'm asking a question.
Okay, but Gage, it's whole class discussion time. Stop that and focus up here. I'm trying to help you, dude. If I'm talking in the front of the room, this is something you need to learn. So, please remember when I look at this equation, this is what's happening first, x plus 2. X plus 2 is being squared. X plus 2 squared is being multiplied by 4. You gotta pay attention to those operations so you know what to undo. And then finally, we're subtracting by 14. The last operation being done is the first one to undo. We gotta keep that in mind. So, if you need examples of the inverses being done, you can see it right here where they took that standard form, they found h and k. I would definitely not have said equals 0, I would have said equals k, because that's what k is. And then they rewrote that standard form as vertex form. They added 14 to both sides. I'll rewrite it just so it's a little bit bigger, but they used the reciprocal, multiplying by 1/4. And every group who did this equation freaked out for at least half a second when they got 14 times 1/4 and they got 7/2. But that's okay. That's just a number. Let the calculator do the work. 14 divided by 4, Saquon, whoever you're responding to, ignore them. Whoever talked to Saquon first, quit. 14 times 1/4 is 7/2.
3 1/2.
Okay?
We did 3 1/2.
Or 7/2, it's the same thing, 7 divided by 2. Now I do want to point this out here, because it's very easy to make your life harder than it has to be. When I see this part, what is my next inverse? Square root. Square root cancels out the square, x plus 2 equals, and guys, you could get a decimal, but guess what? I'm okay with the square root of 7/2. You can leave it like that. What's the only thing I'm missing?
2 1
The plus and minus, positive and negative. Then I need to subtract 2. That's an acceptable answer. -2 plus or minus the square root of 7/2. I'm totally okay with that. So that is a perfectly acceptable option where we look through h and k. Here, I want to look at something that we can all learn from. This is an equation yesterday that I'd said, hey, that could go under factoring or vertex form. But I want you to notice what this group did is they went to the vertex form, and did they make the right-hand side equal 0?
Yes, maybe.
It's still -12, isn't it? So did they make the right-hand side equal to 0? No, they tried to. But here's what I want you to understand. To use factoring, and what key property do we want with factoring? 0, product, property. So,
equation
sir,
How they go from x squared plus 12x plus 20 equals -12
I want-
to x minus
well remember that's vertex form, right? So they showed h here, and they showed k here, and then they just wrote the equation there.
Plus 6.
So I'm going to get there in a second, but hold on. I need you to pay attention to this. To use zero product property, that equation has to equal what? 0. To use the quadratic formula, that equation has to equal what? 0. But the vertex form does not have that requirement. So if you can convert it to vertex form, you can start solving it right away. And so, Saquon, right here, right? H equals negative b divided by 2a. That's the -6. Now, that is something we do need to talk about there. And then k is -6 squared plus 12 times -6 plus 20, which that gives us a k of -16. Now, remember guys, it is x minus h, isn't it? So if h is a -6, we need an x plus 6. But that's all it was, Saquon, that they found h and k here, and then they substitute up here. That's also, guys, why I recommend writing out my vertex form before I start trying to write the actual equation. It helps prevent those errors. And now that they have the vertex form, they just start using inverses. Now, I want you to notice right here.
Can we do factor now?
No, hold on.
Please.
Hold on. This, the square root of 7/2 right here. Is that going to be a nice number or an ugly number? That's going to be ugly, right? It's going to be a nasty decimal. The square root of 11 over there, nice or ugly? Ugly. Right here, though, what is 6 plus 2? Actually, that should be a -6, right? So -6 plus 2. -4. -6 minus 2. Those are pretty nice numbers, right?
Pretty sure.
That means we could have factored it. Anytime you get those nice integers or those nice rational numbers, that means you could have factored it. Now, did using the vertex form work?
Yes.
Yes. The beauty of the vertex form in this case was the equation did not have to equal 0. So if you have not written down the work for your vertex form, go ahead and write that work down now. I think everything is correct up to this point. So write down your equation and write your workout for solving that quadratic equation. After you finish writing that work down, get your textbook out and turn to page M1-93. Learned is going to stay exactly the same. But we are going to get into a new number that this will be the first time you've ever learned that number. It's okay. This new number is actually our first look at Algebra 2 content. This is the first thing that you would not have learned or should not have learned in a previous class. So this is an exciting time.
Imaginary number.
Imaginary numbers. And I know that sounds crazy, like it's imaginary. It doesn't exist, but that's not actually what we mean with imaginary numbers, okay? So, well, you already know a negative number. That's a number you know. This is something completely different.
Before you start, can I go to the bathroom?
This is what's going to be really, really important. You actually don't know every number that
My
exists.
inside.
What?
I'm just that good.
What's Quan? What? You reacted to me saying you don't know every number.
No, I said, we just don't know them all.
Okay. So,
Like, know what they look like. You feel me?
right. So, here's what I want us to talk about. We're going to look here at M1, I believe this is -94. So go ahead and flip the page. In looking at this, it says to list all the key characteristics we know about each function. We could go through the y-intercept, we could go through the vertex, we could go through the axis of symmetry, but there are two things that are the most important. And we need to pay attention to this. First off, we are going to look at zeros and x-intercepts. And I need you to write this somewhere on your page. When we look at solutions of quadratic, actually not even just quadratic equations, of polynomials, which that's just a bigger group of quadratics. We'll study what are called cubics and quartics and quintics, which are x cubed and x to the fourth and x to the fifth and x to the sixth. After this unit, those are called polynomials. So solutions of polynomials are also called zeros and roots. The terms solutions, zeros, and roots do not mean exactly the same thing, but they do have the same values. Okay? So, solutions, zeros, and roots are not exactly the same thing, but they do have the same value. Now, I will point this out. What feature of a parabola have we always connected to roots?
The input.
The input, yes, but for the x-intercepts, right? So this means that solution, zeros, roots are also connected to what?
To
Polynomials. Come on, what did we just say?
Solutions.
Say it again, Jay Sean. Say it again, Jay Sean. Okay, why'd you get quieter with it? Say it louder like you know it. I need a little bit louder.
It's intercept.
Thank
You're
you.
so smart, dude.
Connected to x-intercepts. So listen closely to this. X-intercepts, solutions, roots, zeros, these all are describing the same thing. Hey, Saquon, that's not helping you learn.
Oh, boy.
I'm trying to teach you something new. Open up your book to M1-93 and stop wasting my marker. You still didn't pay for it.
Mr. Kenny.
No, doubt,
No. I want you to learn something, dude. Yes, Shamar. Did you not say Mr. Kenny? Who said Mr. Kenny?
I was trying to see what that word that you squared. What that word is?
Which one?
It said also called
Zeros.
I can't see.
Zeros.
I go to the bathroom now.
I'm not done. So, these solution zeros, roots, they are all connected to the x-intercepts. So let's look at f of x. When I look right here at f of x, what's the x-intercepts?
There is
There's an x-intercept.
Oh, it's 5.
Need a little bit more.
no
5, comma, 0. Notice how the y value is 0?
What you mean, going first one?
It does touch, right here.
I'll talk about 0.
The y value is 0.
Oh, you're asking.
The x is 5, the y is 0, which is why x-intercepts are also called zeros, right? X-intercepts are also called zeros because the y value is 0. That is the x-intercept. Are there any other x-intercepts for that function?
No.
Okay, so let's look at c of x. What are the x-intercepts for c of x?
0, 0,
0,
0.
comma 0,
0, 6.
close.
6,0.
Remember, the x always comes first, right? It's alphabetical. So 6, comma 0, you good? Okay. So there's the x-intercepts. Gage, you with us? Y'all really need to pay attention to p of x here. What are the x-intercepts for p of x?
It is nothing.
Say again.
It don't have.
It doesn't have any,
It's 0, comma 1.
but that'd be a y-intercept, not an x-intercept, okay? Now, here's why this is important. We've connected x-intercepts to zeros and to roots. How many roots has every quadratic function had?
2.
2. When we solve these quadratic equations and we find solutions, how many solutions have there always been?
3.
2, right? So, even though I only see one x-intercept here, how many roots am I supposed to have?
2.
2. Even, and then here with these 2 x-intercepts, that means I have how many roots?
So what's the other root?
2. That's a good question. We're going to talk about it. Here, can I see a single x-intercept?
Yeah.
No. But how many roots are there still going to be? 2. So that should beg the question, where in the world is the other root and where are the 2 roots? Say again.
2, 5,
How'd you get there?
It's coming true.
How's it common sense?
Am I wrong?
I didn't say you're wrong. I'm asking how's it common sense?
Because you should know that.
How do you know that? Does anyone else know?
The math we did 10 years ago, they had to
Dude,
know that.
for so long ago, if they don't know it, they wouldn't pay attention.
Okay. Can anyone else add more onto it, Jay Sean? My question is where, if there's only one x-intercept, where's the other root? Because how many roots are there supposed to be? Supposed to be 2. Well, what form did we most clearly see our roots in? The factored form. So let's look at the factored form of this. A times C is 25. What factors of 25 add up to negative 10?
5. Oh, 5.
5 and 5?
No. Yeah.
Super close.
They add up to negative 10?
That add up to negative 10.
Oh, I ain't hear that.
So it'd be negative
Negative
5
5
and
and negative
negative 5.
5.
There we go. Wow. And so when I go to factor this, I get x squared minus 5x minus 5x plus 25. Greatest common factor for the first 2.
X.
And when I factor out that x, I'm left with
8 minus 5.
greatest common factor here.
5.
Positive or negative?
Negative 5.
So I want to factor out a negative 5 so that I'm
X
left
minus
with
5.
x minus 5. What do these have in common?
X minus 5. Parentheses again, X minus 5.
When I factor out those x minus 5s, I'm left with.
8 minus 5.
So was Saquon correct that we have the same root x equals 5? This is what we call a double root
Double.
of x equals 5.
You want us to write all that down?
Well, you don't have to. If you just want to write the factored form down, that's fine. But I would note the factored form, the x-intercept, and that, oh, that's a double root. x equals 5 twice, that's all that means. And so graphically, what do we see that creates that double root? What do we see on the graph that's creating that double root? And that 1 point would be what, Bryson? So when the vertex is there, we're seeing a double root.
For sure.
That's something huge to notice, okay? So, yeah, you need to write that down for
They
sure.
say x equals 5, but x minus 5.
X equals 5.
True.
Double root of x equals 5. Yes, sir. To ask a specific question, where did you get lost?
Everywhere.
No, can't say everywhere. That's you trying to waste time.
Exactly.
I know, that's why I was talking to him. Where did you get lost?
Issue with.
We're talking about, remember, okay, we're talking about our roots versus our x-intercepts. It's an important idea that how many roots does every quadratic equation have?
2.
2 roots, right? X minus R1 times x minus R2. But here, how many x-intercepts did I have?
1.
And that's okay because I had a double root. It was just that both roots were x equals 5.
That's okay, because we can find.
Here, I had 2 x-intercepts. So what are the roots? X equals 0 and x equals 6. But Jay Sean, look at the factored form. R1 is 5, R2 is 5. So it's the same, it's just the same root shows up twice. That's why the vertex is on the x-axis. Right. It's 1 x-intercept, it's still 2 roots. It's just the same root. Okay, that's all it is. I don't know, because you were mumbling, so I couldn't tell. You just acted like you were confused and didn't know what was going on. Okay. So the issue then becomes here, guys. Look, how many x-intercepts do I have? None. So I can't have a double root. I don't have 2 real roots, but I still have to have how many roots? 2. There's still 2 roots. There's still 2 solutions. So this is where we would want to say, what are the roots? And that's what we're about to talk about. That's what the last thing that we're going to learn is, and it's a very small but important detail. So, right here, consider the function p of x. It's distracting me. Consider the function p of x equals x squared plus 1 and its graph from the getting started. So this is the one we just said had how many x-intercepts?
0.
No x-intercepts, but it still has to have how many roots?
2.
So, when we look right here at this work by Elena and Mark, they're determining the what? The zeros, which are the same values as the roots.
Yeah.
But it's called a 0 because what did they substitute in for p of x?
0.
0. Right? They substituted 0 in and they solved it. And Elena worked through it and got x equals positive, negative, square root of negative 1, whereas Mark got x equals positive, negative 1. What I would point out about what Mark is saying is, Mark is saying that the zeros, or the roots, are x equals 1 and x equals negative 1. That's what Mark is claiming. But number 1 says, what did Mark do wrong? And use the graph to justify your answer. So Mark went wrong somewhere. Look through his work, look at the graph, and tell us where Mark went wrong. I'm going to give you 90 seconds to talk about it as a small group, then we'll talk about it as a whole class. So 90 seconds, and go.
She just called us.
They'll call back then on the phone if they need to. So, talk about it. Let's go.
You did that, man. Talk about that woman. I'm gonna wait till they do it.
It's just a function name, right? F of x, p of x, q of x. Just functionalization. So the question is, what did Mark do wrong? Well, they're telling us that the roots are not x equals 1 and x equals negative 1. So where did he go wrong? And also, why does the graph tell us that?
Yeah, he didn't do the script.
Come on, talk about it.
Mark didn't do the script.
Let me ask you this. If what are zeros and roots connected to? Solutions and x-intercept. So if the zeros are x equals 1 and x equals -1, what should I see on the graph? Well, 1, 0, and -1. Do we see those x-intercepts of 1, 0 and -1, 0? So did Mark do his work correctly? Okay, so let's figure out where that went wrong, okay? What are we talking about? What about Mark? Where are you going? He didn't just plug it in wrong. Why are you stressed? So you don't have to right here. We can use inverses if you have vertex from, right? Where do you think you got the plus or minus from? Thank you. Thank you. Okay? So, let's talk about some key details here. What did Mark do wrong? Use the graph to justify your response. What did anyone discover about that idea?
Everything.
No, what does that mean? I need specifics. Okay, raise your hand if you want to share ideas. So, Sam?
Are you gonna use the radical?
Okay, or that square root, right? Okay, so if Mark didn't use the square root, where do you think he got the positive and -1 from? So maybe he did use the square root, just maybe use it incorrectly, so that's a good idea, right? Jay Sean? Okay, well the book is telling you he did, and I'm telling you he did. He made a mistake. Like, don't put me on that. It's like on the test when I told you these equations are correct, and you're like, these equations are wrong, Mr. Kinney. I'm like, no, they're correct. Tell me why they're correct. So Z. Okay, Z. What did we talk about in your group?
About
Not just that. We talked about the graph, I think, in your group, didn't we?
yeah, like the graph is right. It's like the other one.
Excuse me, sorry, there are people talking, which means they can't be listening. Okay, Z, can you start over again? Jay Sean, listen to what Z says.
It's like the PX graph on me. It's like raised up where, like, when you eradicate, she moved it. I was like,
Okay, that was something with it. Janiyah?
The roots don't match up with the graph.
If we're saying that we have these roots, what should we see on the graph?
The roots. Those.
How do we see roots on the x or on the graph? On the x-axis says x-intercepts. Do I see x-intercepts in -1, 0, and 1, 0?
No.
No, those don't exist. So if we don't see those x-intercepts, then those can't be roots. So right here, those roots don't exist on the graph as x-intercepts. So they don't exist, right? If those roots are not x-intercepts on the graph, then they don't exist. And so this gets us into what Sam was referring to earlier when he said Mark didn't use the square root. Now, what I would say is for Mark to go from x squared to x, he had to use the square root. That's also why I got the positive and negative, but he may have used it incorrectly. If this is correct, what is Mark claiming the square root of -1 is? Well, and we do the positive negative because we took the square root, but that means he thinks the square root of -1 is 1. Is the square root of -1 1?
No.
How do we know? Okay, what Janiyah is referring to is if I do 1 squared, what do I get?
A positive.
A positive 1. So that means that the square root of -1 is not 1, right? If I take the square root of 4, that is equal to 2, and that's because 2 squared is 4, right? If the square root of negative 1 is 1, then that means 1 squared is negative 1. Is 1 squared equal to negative 1? No. And so that's what we need to note, is that is not a true statement. So where did Mark go wrong?
Square root.
He claimed, or he thought, the square root of negative 1 equals 1, but it doesn't.
You right.
The square root of negative 1 does not equal 1. Because I know that 1 squared is 1 and not negative 1. He thought the square root of negative 1 was 1, but it does not. Or he thought square root of negative 1 equals 1, but it doesn't. But Elena's solution actually has some key ideas. The question in number 2 says, does the solution fall within the real number system? Well, the square root of negative 1, it has to equal a number, correct? Something. KP, you focused? The square root of negative 1 has to equal a number. I'm going to just put a box here to represent whatever it equals. But that means that this box, when squared, would have to equal what? Negative 1? Can someone give me a number that when I square it, I get negative 1? Say again? Negative 1? But if I square negative 1, that means negative 1 times negative 1, which is what? A positive 1. Not a negative 1. In fact, and this is important, I want you to think through this. If I take a positive number and I square it, what kind of number do I get?
Positive.
A positive number squared is always a
Positive number squared.
What's a negative number squared?
Positive.
A positive number.
Why?
Because a negative times a negative is positive?
I don't know what that was.
Yep, it is. So we now need a number that when it is squared gives me a negative.
Alright.
And this is where, oh, and so notice here, does Elena's solution fall within the real number system?
Definitely not.
If it did fall within the real number system, this graph would intersect the x-axis, right? The x-axis is all real numbers. So does it fall within the real number system? No. The roots aren't on the x-axis. The roots are not on the x-axis. And I need you to pay attention for about 30 more seconds because this is the most important detail of today.
Okay.
How are we?
Okay?
30 more seconds.
So, right here, in order to calculate the square of any real number, we have to be able to get a number squared that equals negative 1. For that reason, y'all, that means don't pack. Pay attention for those y'all packing. For that reason, mathematicians created the number I and defined I such that I squared is negative 1. That's the definition. I stands for the imaginary number. This is so that when I square something, I can get a negative.
Oh, so all I gotta do is just put I in the calculator.
So if I square 2i, I get 4i squared. What is I squared? So this becomes 4 times negative 1 or negative 4. The number 2i squared gives me a negative. Negative 4. So we need to notice we're going to talk more about this number I and I squared tomorrow. What is due tonight? You're running into problems. I cannot help you if you do not trust with me.
No way, yeah, no problem.